Hi, and welcome to the video on combining functions. Our learning objectives are today to combine function using algebraic operations, create new functions by composition of functions, evaluate composite functions, and then we're going to talk a little bit about even and odd functions. So let's go ahead and get started. All right, the first way we're going to combine functions is just to use regular sort of arithmetic that we are all familiar with. So we can add, subtract, multiply, and divide functions to get a new function. Oh, I don't really want that. Okay, so let's look at an example. Let's say our first function, f of t, is t plus 1, and our second function, g of t, is equal to t squared. So we're going to make new functions by adding, subtracting, multiplying, dividing these. So in example A, we're going to add them, and we're just going to follow our instinct and add them up. So f of t is t plus 1. So that's what I'm substituting in for f of t. And g of t is t squared. So my final function is t plus 1 plus t squared. Now, you don't have to do anything to simplify that. I personally like to put it in order of decreasing degree, so highest exponent to lowest. So I would write it as t squared plus t plus 1. But either answer is correct. All right, let's try the second one. K of t equals f of t minus g of t. So f of t is t plus 1. G of t is t squared. So this is our final function, t plus 1 minus t squared. And again, if you wanted to reorganize that, you would have minus t squared plus t plus 1. All right, let's try the next one. F of t times g of t. So that's going to be t plus 1 times t squared. And again, you could leave it like that if you wanted to. Maybe it'd be good to FOIL it out. I'm going to go ahead and do that just for practice. So I'm going to go distribute it out. So t squared times t is t cubed, and t squared times 1 is t squared. So I'm going to write that as t cubed plus t squared. And then finally, let's do our last one, which is f of t divided by g of t. So f of t is t plus 1, and g of t is t squared. And we want to make sure we don't let g of t equal to 0, so this domain is going to be not 0. We can just write all real numbers but 0. And that's the only one we really have to worry about the domain about. So if we wanted to write that in interval notation, that would be minus infinity to 0, union 0 to infinity. So adding, subtracting, multiplying, dividing functions is pretty straightforward. Let's talk about another way we can combine functions, and that's using composition. So when we insert one function as the input into another function, we call that composition. The notation we use for that is, there's two. There's f of g of t, or we also use f of g of t with this little circle. Those both mean exactly the same thing. So f circle g of t is read f of g of t, and it's the same as f of g of t. So those two mean the same thing, and you'll be expected to know both those notations. Let's look at an example of how this works. So let's let our f of x be equal to 2x plus 3, and our g of x equal to x minus 2. So we're going to find a whole bunch of different function compositions because we can compose them any way we want. We're going to put g into f of g. We'll put f into g, and we'll put f into f. Let's do the first one. So the first one is f of g of x. So we're going to go into our function f, and we're going to insert x minus 2 as our input. So if we're using our function rule of 2x plus 3, everywhere we see an x, we're now going to put x minus 2. So that's going to be 2, and not x minus 2 plus 3. So just looking at our function f, and everywhere we see an x, now we put in x minus 2. Let's go ahead and simplify, distribute. 2x minus 4 plus 3 is 2x minus 1. All right, let's try the other way. Let's try g of f of x. Now, you'll notice that in function composition, order is very important. F of g is different than g of f. And so in this function, our outer function is g, which is x minus 2. And what we're plugging into it is our f, which is 2x plus 3. So in our function g, everywhere we see an x now, we're going to put 2x plus 3. So looking at g, maybe I'll switch colors. Here's our function g. and it's x minus 2. So everywhere I see an x, we put everywhere I see an x and x minus 2, we're going to put 2x plus 3. So 2x plus 3 minus 2. So that gives me 2x plus 1. And you can see that f of g and g of f are not the same. They look similar, but that's just a coincidence. So what I would like you guys to do now is I would like you to try to compose f with itself. So I would like you to find f of x. So pause the video and just give it a try. All right, did you do it? So our outer function is f and our inner function is f. So I'm going to find f of 2x plus 3, which is 2. And now I see the x, so I put in 2x plus 3 plus 3. And let's go ahead and simplify. 4x plus 6 plus 3, which is 4x plus 9. And you could find g of g too. That would be fine. Let's go ahead and keep moving on. Let's think about function composition using tables. So same idea, we're going to have an input function, an inner function, and an outer function. Let's go ahead and just jump in with an example. So our first example, we have two tables. We have the top table is h of v, and the bottom table is g of v. So here's our input to h, and here's our output to h. And here's our input to g and our output to g, looking at our tables just to see what we have. And the first thing we're trying to find is g of h of 7. I'm going to go ahead and rewrite this because I think sometimes it's helpful to rewrite it using this other notation. G of h of 7. So I'm going to work inside out. So the first thing I need to find is h of 7. So I go to my table, and my input is 7. Here's my input of 7 in my h table, and that gives me an output of 6. So h of 7 is 6. And so I'm finding g of 6. Because h of 7 was 6, so I replace h of 7 with 6. And now I have another step to do. Now I'm just finding g of 6. So this is just regular old function notation. So I look at my function table for g. For an input of 6, the output is 10. All right? So g of h of 7 is 10. All right, I'm going to go ahead and erase this so I can follow along with my next one, so I don't have the table all messed up. All right, let's try another one. Let's try g of h of 5. So I'm going to work on the inside first, h of 5. So I need to find my function h. That's in the top. The input is 5, so the output of 2. So h of 5 is 2, so this means I need to find g of 2. I look at my g table. G of 2 is equal to 3. So my output is 3. All right, so what I'd like you guys to do now is go ahead and try the next two problems on your own, but I don't really want you to do g of 6. I actually want you to do h of 3. I will adjust this in the notes. H of 3. So go ahead right now, pause the video, and figure out h of g of 2 and h of 3. All right, how'd that go for you guys? Let's go over this one together. So in the first one, the first thing I need to find is g of 2. So looking at my g table, and I have an input of 2, that gives me an output of 3. So this means that I have h of, not g of 2, but replaced by 3. Going up to 3 in my h table, an input of 3 gives me an output of 7. So h of g of 2 is 7. And let's find h of 3. Let's just go ahead and erase this so we don't get confused because that's right where we're starting. All right, let's see. So h of 3, using our table right here, is 7. So that means I'm finding h of 7. I go back to h again. My input is 7, gives me an output of 6. So h of 3 is h of 7, which is 6. Okay, hopefully those are feeling pretty good now. Let's do a story problem example. Let's think about two functions. We have two functions, q of t and h of q. Q of t will tell you the quantity of water in a container after t seconds. So if we think about q, what goes into q is time in seconds. And what comes out of q is how much water, so volume. and that's in centimeters cubed. So it will tell you how much water is in a container after so many seconds. Now let's think about the function h of q. H of q gives you the height of water in a container filled with q quantity of water. So what goes into h is volume in centimeters cubed, and what comes out of h is height in centimeters. So this means that you have some sort of a container that you know something about the dimensions in. And if you know the volume, like maybe it's a cylinder and you know the radius. If you know the volume of the cylinder, you can figure out what the height is using a formula. So what does h of q of t represent? So if we combine these two functions and we put q into h, our input into h of q is the t still, right? So we're still putting in t, so that's time. And what we get out from q of t, just like before, is volume. However, now we take that volume and we make it an input into h. So this is our q. And this is our h. We put volume into h and we know we get out height. So if we go all the way from the beginning to the end with this, oops, I didn't mean to do that. If we go all the way, seriously. If we went all the way from the beginning input of time and we skipped all the way through to the end, we would put in time and we would get out height. So what does h of q represent? It represents a function that gives the height of the container as a function of time. So these little in and out tables really help me. So Q takes in time, spits out volume. H takes in volume, spits out height. So if we go all the way from the input to Q to the output for H, we put in time and we spit out height. So therefore, that function h of q of t represents height as a function of time. All right, let's try composing functions with graphs. And really, this comes down to a little bit more about just doing tables to begin, but let's give this a try. So we have one graph of m, that's our first graph. This is m, and our second graph is k. Wow, I'm really short on parentheses here. So this is m of x, and this is k of x. All right, let's try to find the first one. The first one says m of k of 1. So we're going to find k of 1 by using our graph, and we see input of 1 gives me an output of 3 by looking at my point on the graph. So this is m of 3. And so now I go over to m, and I find 3. Here's 3. And I look at my output of 3. And it's -6. That's the 0.3, -6. So m of 3 is -6. So really, it's sort of like translating a graph and an output to a table and then using those same values. So why don't you guys try and find the other 3, pause the video and try and find these, and then I'll come and do them with you. All right, how did that go? Hopefully it went smoothly. Let's give this a try. Let's try m of k of 2. Well, this is going to be m of, well, what's k of 2? Here's k, here's 2. K of 2 is 2. So this is just m of 2. Make sure I go to the m graph. M of 2 looks like -1 to me. So m of k of 2 is -1. Let's try k of m of 0. So again, we work inside. So m of 0, go to my m graph, go to 0. Looks like m of 0 is 3. So m of 0 is 3. Now I need to find k of 3, which looks like it is +1. And finally, k of m of -2. So the first thing I'm going to find is m of -2. Go to my m graph, go to -2, and I get a -1 out. K of -1 is 5. So just reading inputs and outputs and just remembering you start on the inside and you work your way out. All right, last topic for this video is even and odd functions. So even functions are functions that are symmetric about the vertical axis. And this means whatever negative input in, we get the same positive output. So when I think of even functions, I like to just think about x squared. Right? And if I think about what x squared looks like, it's symmetric. I'm not a great artist. It's symmetric about the y-axis. If I folded it on the y-axis, it would match left and right. And if I put in f of 2, I get the same thing as I put in f of negative 2. Odd functions are symmetric about the origin. This is a little bit harder to look at, but really I think about like a double fold, okay? And when I think about odd functions, I like to think about, oh, I didn't write this down. I like to think about x cubed. And x cubed looks like, I'm not the world's best drawer with this pen, but it looks more or less like this. That actually wasn't the worst. Let me try that again. Actually, I can do better than that. I can do better than that. Let me try that again. Okay, try that again. Here we go. Got it this time. X cubed. Okay, that's pretty good. I think about x cubed, and if you think about symmetric about the origin, it's like you fold it twice. So you fold it up, and then you fold it right, and you would see that those two would match. So let's think about whether we need to determine if a function is odd, if it's even, and some functions are neither. So let's look at f of x equals x squared minus 2x plus 2 and decide if it's odd, even, or neither. And the way you check this is you just check f of minus x. And this is sort of very beginning level composition of functions. So my inner function is minus x, and my outer function is x squared minus 2x plus 2. And if I want to find f of minus x, everywhere I see an x, I put in a minus x. So minus x squared minus 2 times minus x plus 2. All right, so f of minus x equals minus x squared minus 2 times x plus 2, which is equal to x squared plus 2x plus 2. Checking my negative signs. Now, if it's even, it'll equal f of x. If it's odd, it'll equal minus f of x. Well, this definitely is not equal to f of x because this has a minus 2x and this has a plus 2x. But it's also not equal to minus f of x, right? Because that would be minus x squared plus 2x. That would be minus x squared plus 2x minus 2 if we flip all those signs. And it's not equal to that either. So our answer to this one is neither. It is not odd. It is not even. It is neither. Let's try the next one. Oops, what did I do? Let's check to see if x cubed minus x is odd, even, or neither. And again, the way you check this is you just look at f of minus x. So you compose minus x with the original function x. So everywhere I see an x, now I put minus x. Minus x, quantity cubed, minus x. All right, so minus x cubed is minus x times minus x, which is x squared, times minus x, which is minus x cubed, plus x. Now, this is definitely not equal to f of x, so we know it's not even. What about odd? Well, minus f of x would be minus x cubed plus x, switching the signs on all my original function. And yep, sure enough, those guys are equal, so this one is odd. I know these do say check by graphing. I'm just not going to do that right now. You can go into Desmos and graph these and see that this one is symmetric about the origin. All right, that's it for this video.